What is capacitor? You see here the two bar lines. This is the symbol of the capacitor. This is fixed capacitor. And that is variable capacitor. What is capacitor? A charge storing device is called capacitor. An arrangement of two identical, an arrangement of two conductors separated by an insulating medium that is used to store electrical charges. That is used to store electric charges and electric energy. Yes, an arrangement of two conductors capacitor. Capacitor is fixed when the value of the capacitor to store the charges does not change. The two plates store the charges. If one is storing positive charge, other stores negative charge. And then another symbol of the variable capacitor is the arrowhead crossing the two plates. We used to show it as variable capacitor. If the system of the two conductors stores the charges, what is the capacity to store the charges by the two conductors? Let us see how to store the charges and how to define the capacitance. If capacity is there is some capacity to store the charges, and how to decide the capacity, it is depending on how much the potential of the plates to store the charges are there. So, coming to the another so capacitance. Capacitance, to understand the capacitance, we know that the capacitor consists of the two conductors. You just think of, we are taking any conductor here. We are having any conductors here. The total charge is here. Positive charges are given to the surface of the conductor. And potential of this many conductors is the V positive. And near to this many conductors, we once again place another conductor. And there is one charge stored on that. Negative charges are shown here. Potential of this conductor is E minus. So when For the two conductors, conductor left side and conductor right side. First of all, we will decide the potential difference between the two conductors. We write the potential difference between the two conductors. Suppose it is equal to for the one system of the two conductors, and this value is decided in the high potential of the one conductor minus low potential of the second conductor. So when the potential difference between the conductor is positive minus B negative, the charge is loaded by the one conductor, positive charge, and the other negative charge. Here we call it the Q is the amount of charge, is the amount of charge on the capacitor. And this very charge on the capacitor does not mean that the total charge given to the capacitor is zero. If we are writing here positive charge and negative charge to the two different conductors, it does not mean the total charge of the capacitor is zero. So you should bear in mind that if you are giving the charge plus or minus to the conductor, it does not mean the capacitor has zero charge. So take care of charge should not be zero here because our capacitor amount of charge is stored by it is capital Q. And this very Q, amount of charge is stored on the capacitor is directly proportional to the potential difference. So the Q, total Q is directly proportional to the potential difference between the two conductors. If this very amount of charge is stored by the capacitor is directly proportional to the potential difference of the two conductors, we will write here one new equation.
सर एक मिनट मिटाइए नहीं सर.
Yes.
छोड़ दीजिए सर, मिटा दीजिए, अब मिटा ही दिए तो.
Potential difference is B, and this very amount of charge is directly depending on Q. Because amount of charge is going to be directly proportional to D, it means that we write the value of the Q as any constant multiplied with the D, and we take it as equation 1. Here, T is multiplied with the potential to remove the proportionality. T can be written in terms of the total charge and the potential difference. The ratio of the amount of charge and potential difference gives a constant value for the capacitor and called capacitance of the capacitor. So, how to write the formula of capacitance of the capacitor? It is Q divided by D. This constant of proportionality is called this constant of proportionality, that is capital C, is called capacitance of the capacitor. So this is very simple terminology utilized here. If any system of the two conductors stores the charge separated by the insulating medium, how much the amount of charge stored by the capacitor depending on the potential difference between the two plates or two conductors. And this capacitance, we just, you have to define it out. Ultimately, you can define capacitance of a capacitor capacitance of a capacitor is defined as the amount of charge required to be supplied to either of the conductor. The charge required to be supplied to the conductors, either of the conductors, either of the conductors. Either of the conductors. Of the capacitor. So as to increase the potential difference between them by 1 volt. So as to increase, the potential difference by 1 volt. By 1 volt. This is the standard meaning of the capacitance. Actually, it is the total capacity of the capacitor to store the charges, which is required by the each plates, so as to increase the potential difference between the two conductors by 1 volt. So after writing this formula, you just see here. C is Q by V. If you are putting 1 volt, then C becomes Q by 1. So capacitance is nothing but the total amount of charge required to store on each capacitors, each plate of the capacitor, to raise the potential difference between them by 1 volt. It means when we have come to know the concept of the capacitance, how to write the SI unit of the capacitance. SI unit of the capacitance one coulomb by 1 volt, it will help us. But you write farad, capital F. This is the symbol of SI unit of the capacitance. How to decide the 1 farad of capacitance? Capacitor has a capacitance of 1 farad. If 1 coulomb of charge is transferred from its one conductor to another, by applying a potential difference of 1 volt between the two conductors. So, SI meaning of the one conductor. The capacitance of the capacitor is said to be 1 farad when 1 coulomb of charge is required to store by applying a potential difference of between them by 1 volt. So this is the SI meaning of the capacitance of the capacitor. If the one potential difference is applied across the plates of the capacitor, so that the total amount of charge is stored by it under this condition, give us the value of the capacitance. Then capacitance is said to be 1 farad. Okay? So after knowing the concept of the capacitor and the capacitance, our purpose is here to how does the capacitor work? How does the capacitor work? What is the main principle of capacitor? Come to the point of the principle on which the capacitor works. So write the topics now. The second topic, principle of capacitor. Principle of capacitor. This is also very important. In most of the examination, this very question has been asked. Explain the principle of capacitor. Now let us see how to explain. Let us see. First of all, you take one capacitor plate. We have drawn a plate of the capacitor. For simplicity, we have taken the name of the capacitor as A is the one capacitor. And we have given the charges over the surface of the capacitor plate. Positive charge is given to the one plate. When you have taken one plate, positive charge plate, you may write plus here, given to the plate. And we don't know, we have taken another identical plate also in the neighborhood of the first plate. And we place the plate number B, second identical plate B, which is uncharged. No charge has been given. If one positive charge has been taken here in the first stage, and another uncharged plate is brought in the neighborhood of the positive charge plate, what happens to the system now? It is seen that due to the positive charge plate, 1, 2, 3, 4, 5, and 6 number of positive charges we have distributed over it. It is seen that on the plate B, equal number of opposite induced charges are produced on the surface of the conductor. Uncharged, second plate is uncharged. Uncharged plate. of the capacitor. What happens if the induction take place? So due to the induction, negative charges are produced on the left surface of the second plate. You can count how many number of induced charges are produced. Due to positive charge, induced negative charges are produced on the left surface of the conductor B or plate B. So similarly, the left side of the plate B, due to induction, induced negative charge produced. At the same time, to the right side of the second plate, induced positive charge also produced on the surface of the second plate B. So due to induction, we used to write positive charge. This is nothing but the induced positive charge developed in the right side of the plate B. So in the second stage, we see that due to induction, induced negative charge, induced negative charge develops to the left side of the plate B. Induced negative charge developed to the left side of the plate B. And at the same time, induced positive charge also produced on the right side of the plate B. And induced negative charge also produced to the right side of the plate B. Yes, these 2 points are very remarkable. When positive charge plate is taken in the first stage, it is seen that after some time, due to the induction, due to polarization, induced negative charge as well as induced positive charge are produced on the same plate B. The induced negative charge develop near to the positive charge of the plate A and induced positive charge develop to the right side of the plate. What happens then? How to decide how the capacitor stores the charges when there is induction of the positive and negative charges. If there are two kinds of induction taking place on the one kind of the plates B, which is uncharged, and induction causes to develop the negative charge over it and positive charge over it. It means what is the effects on the potential of the capacitor. If the plate A is positive charge, high potential is stored by the plate A. If no charge is given to the plate B, no potential is there. So what is the potential difference between the two plates initially? P plus minus 0. So we have only high potential in the first stage. In the second stage, we see that the positive charge is giving the high potential as usual. But the polarization causes to develop the negative charge to the neutral side and induce negative charge, which decide the potential difference also, reduces the potential of the system. At the same time, the positive charge induced developed to the right hand side of the plate B increases the potential of the plate B. So it is seen that the induction of the negative charge reduces the potential and induction of the positive charge increases the potential. So what happens to the capacitor when the two kinds of induction taking place in the same plate? How the capacitor will store the charge? So we once again do the third activity here to decide the exact principle of the capacitor. Now let us see. We will make once again the tendency here. It is already kept at with the positive charge of the body and the neighboring second plate B where the negative charge have already developed due to the induction to the left hand side of the plate B. Now the process is that when we make an arrangement of the earthing, when the plate, right side of the plate B earthed, when the ground is being done, when the plate B, the right side of the plate is grounded and earthed, so by that, whole of the positive charge cancels out with PR and comes to 0. So when the right side of the plate B is grounded, earth here, the whole positive charge vanishes. And what is the effect on the capacitor to store the charge? Now come to the point here. We know that C is equal to Q by K. Okay, we know that C is equal to Q by K. By grounding the right side of the plate B, it is seen that now we are having the here. Yes, by grounding the right side of the plate B, what happens? The net potential of the capacitor diminishes, and hence the capacitance increases appreciably and stores the charge as C is inversely proportional to B. So when C is inversely proportional to the B, when C is inversely proportional to the B, due to the earth of the plate B, due to the inverse relation between the Q and P. Okay, so this is the process of and principle of capacitor. We will all note down this. We will all note down this, and you may say, you may ask any question relating to the principle of capacitor. Any of you? So this question has been asked 1, 2, 3, 4, 5. So many times board has asked this very particular question of explaining the principle of capacitor. The conclusion you may take within 1 minute, we can conclude here. The capacitance of a charge capacitor is is by the bringing another and the earth near it, and conductors remain separated with the non-conducting medium in between the two plates. So ultimately, the purpose is to, by earthing the plate B, potential difference between the plate decreases, and hence capacitance of the capacitor increases, which is called the principle of capacity. Okay, you will all revise and take care of your studies.